Pythagorean identities look like this. Sine squared theta plus cosine squared theta equals 1. And tangent squared theta plus 1 equals secant squared theta. 1 plus cotangent squared theta equals secant squared theta. Then we also have quotient identities. Quotient meaning, division basically, but you've got tangent theta equals sine theta over cosine theta. And then cotangent theta is just the reciprocal of tangent, so that's cosine theta over sine theta. We're going to have a lot of identities and a lot of formulas this semester. You won't have to memorize them all. I'll probably give you a formula sheet, but notice the two that I wrote in red. I think you're going to want to have those memorized as soon as possible. Okay, the ones in green you'll probably have on the board or on a paper or something like that. I might not remember those or memorize those, but the ones in red, you use those all the time. Example x3, find sine theta and tangent theta given that cosine theta equals negative 3/4 and sine theta is greater than 0. Okay? So there are going to be two ways of doing this problem. Either you're going to do it by graphing it, or you're going to be doing it by using those formulas that we just wrote down. Okay? Honestly, almost everyone in here will have an easier time drawing the graph. So let's do that first. Okay? I'm going to show you that first. If you draw the graph, you better figure out what quadrant we're in. So notice that cosine is negative. Cosine is negative. So that would imply that we're either in quadrant 2 or 3. Because that's where the x numbers are negative. But here, this says sine theta is positive. And sine theta being positive, those are the y values. Those are upstairs. Imply that we're either in quadrant 1 or 2. So if you put those two things together, where's cosine negative and sine positive, that means we must be in quadrant 2. I know we're in quadrant 2. Put those two pieces of information together. Okay, so if I was going to draw a picture of this, I've got some theta putting me into the second quadrant, but that defines a right triangle here. We've got this right triangle, and they've given us one of the relationships, the cosine relationship. Remember, cosine goes with x, so it's x over r is negative 3/4. So the x, I'm going to call that x negative 3. I realize you can't have a negative side of a triangle, but it's just numbers here, and that's going to help me with my ratios. And r is 4, negative 3/4. So what I want to do here is I want to find that missing side. I want to find that y side, and that's just Pythagorean theorem. So I would go y squared plus x squared equals r squared. Notice I skipped a step. Subtract 9 over, that's going to give me y squared equals 7. I'm going to take the square root of both sides. I'm either looking at plus or minus the square root of 7. Now, since we are in the second quadrant, I know that y values are positive. And so I would only be looking at the positive value. That's the square root of 7. Okay? So when they want me to, when they want to know sine theta, they're asking me sine theta. I know sine theta is y over r. Square root of 7 over 4. Notice that's a positive value. That's good because we're upstairs in the second quadrant. They also want tangent theta. Tangent theta, that's y over x. Y over x. So the y over the x, I'm looking at basically negative square root of 7. Okay, so there are my answers. That's a graphical way of doing it. Graphical meaning I drew a picture. Geometric, I drew a picture. I suspect the authors of this question, though, wanted us to do it the algebraic method. So I'm going to show you that. Okay, I'm going to show you that. They gave me cosine, and they asked for sine. I've got a formula that puts those two things together. Sine squared theta plus cosine squared theta equals 1. And so, since I have cosine, and this formula is going to square it, I'll just square that negative 3/4 and get 9/16. I would have sine squared theta plus 9/16 equals 1. I need to solve it. I need to isolate the variable. In any equation where you only have one variable, you should be able to isolate. So I'm isolate it just like this was, pretend like this was x squared plus 9/16 equals 1. You should have no trouble solving that equation. It's basically the same idea. So I'm going to subtract 9/16 to try to isolate the variable. I've got a 1 minus 9/16. I'd better change it to a common denominator. So change that 1 into 16/16 so that you can subtract your fractions. You got sine squared theta equals 16 minus 9 is 7/16. I need to ISO my sine theta. I need to ISO my trig function there. So I'm going to take the square root. Actually, it's the plus or minus square root. Okay. So sine theta is going to equal plus or minus square root of 7 over 4, because the square root of 16 is 4. Now here's where that quadrant 2 comes in. Okay? We know we're in quadrant 2, and that means sine is positive. And so we would look at the positive sign. There's my square root of 7 over 4. Okay, but now I need tangent. And there are a couple of ways to do it. You could use another Pythagorean identity, or you could use a quotient identity, one or the other. It's probably going to be easier to use your quotient identity. Tangent theta equals sine theta over cosine theta. We just found sine theta was square root of 7 over 4, and we were given that cosine theta was a negative 3 over 4. So if you divide those two fractions, you can think about it as multiply by the reciprocal, but those 4s are going to cancel out. Okay? If you multiplied square root of 7 over 4 times 4 over negative 3, those 4s are going to cancel out. And you're getting tangent theta equals negative square root of 7 over 4. Okay? Same answer. Same answer algebraically as we got geometrically. I think most of you are going to prefer to do it geometrically, but there are always a few that would rather do it algebraically using the identities.